Hello guys, welcome back to Techdose, and in this video we will see the Decode XORed Permutation problem, which is from Leetcode number 1734, and this is from Math Algorithms. The prerequisite for watching this video is to watch my video on finding XOR in a range of numbers. So the link for this video will be present in the description below. You can go there and watch this. Even if you haven't watched this, you can still continue with this video. If we recap about how XOR works, then 1 XOR 1 will be 0, 0 XOR 0 will be 0, 1 XOR 0 is 1 and 0 XOR 1 is 1. So if you have even number of ones, then it will be 0, and if you have odd number of ones, then your result will be 1. This is how the XOR operator works. I would like to announce about our DSA live training program, which will guarantee understanding of every programming concept. It makes you interview ready in just 3 months. And it will maximize your offers so that you get the best possible pay and in the best possible company you can. All the sessions will be live interactive sessions, so you will get the feel of a live class and you can ask all your doubts throughout the class. In order to get more details, please WhatsApp us on this given number. Let us now look at the problem statement. In this problem, there is an integer array permutation, which is the permutation of first n positive integers, where n is always odd. It was encoded into another integer array encoded of length n-1 such that encoded at I is equals to permutation at I XOR of permutation of I plus 1. For example, if the permutation array was 1, 3, 2, then our encoded array will be 2, 1. This 2 was formed by doing 1 XOR 3, which is the first two adjacent terms, and this 1 was found by doing 3 XOR 2, which is the next two terms, right? Given the encoded array, we have to find out the original array. So from the encoded array, we need to find the permutation array. It is guaranteed that the answer exists and is unique. Now let us look at the problem constraints. Problem constraints are always very important. In this case, it is said that n will be less than 10 to the power 5. N will always be odd. So our permutation array will always be odd, and the encoded array length will be n-1, which will always be even. Let us now look at some examples in order to get a better understanding. Now, given the encoded array, our goal is to find the output array. That means our goal is to find the permutation array from the given encoded array. Now let's say the encoded array is 3, 2. How was this formed? If we assume that the permutation array is ABC, that is what I am assuming because I don't know what the elements are. According to the problem statement, if the permutation array is of size 3, then it will contain the first 3 natural numbers, that is 1, 2, 3, in certain order. It can be ordered or it may be unordered. We don't know about it. Therefore, we cannot write 1, 2, 3. We have to write ABC, right? So if the permutation array is ABC, then the encoded array can be derived as the first element of the encoded array will be A XOR B and the second element of the encoded array will be B XOR C. This is how we can define the encoded array. Now in this case, since the encoded array is given, this 3 means you are given the value of A XOR B, and this 2 means you are given the value of B XOR C. So given A XOR B and B XOR C, can you uniquely find all the values of A, B, C? That is the problem statement. So some of the observations which we can derive from the problem statement is the permutation array is an unordered array with all unique elements from 1 to n. The size of the permutation array will always be equals to 1 plus the size of the encoded array. And since n is always odd, therefore the size of the permutation array will be odd all the time and the size of the encoded array will be even all the time. Now let us solve an example in order to understand how we will approach this problem. So let's take a longer problem statement. In this case, the encoded array is 6, 5, 4, 6. Now let the permutation array have 5 elements, because if the encoded size is 4, the permutation size will always be 5, which is n, right? So let's say all the elements are A, B, C, D, E. Now in this case, this 6 will be equals to A XOR B. This 5 will be equals to B XOR C, and this 4 will be equals to C XOR D. This 6 will be equals to D XOR E. That is what I have listed here. If you can see, I have listed it here. Now this is the information which is provided to us. and we know that the permutation array will be in the range of 1 to 5. Certain ordering of numbers from 1 to 5 will form the permutation array. That is known to us. Given these two informations, we are required to find all the unique elements A to E in that exact same order, whatever it was given in the permutation array. Now this can easily be done if you know the XOR property. What is the XOR property? The XOR property says that if you take a number, let's say a number n, and if you XOR it with the same number n, then you will always get the answer as 0. So if you take A XOR n, then your answer will be A. That is, if an element occurs even number of times, that will get cancelled out. In the similar way, let's say that you have this piece of information which says that D XOR E is equals to 6. Now let's say that you know the value of E is 3. We are just assuming that you know the value of E is 3. If you know this, then we can XOR this item, XOR it with E on both sides, and your answer will not change. Now what happens is this two E's will get cancelled out and you will be left with a D. And on the other hand, on the right side, you will have 6 XOR 3. Now you know the answer for this, right? The 6 is 1, 1, 0 and 3 will be 0, 1, 1, which will give you an output of 1, 0, 1, which will be equals to 5, isn't it? So your D value is equals to 5. This is how, if you know at least one unique element, then we can easily derive the rest of the element. I had assumed that I know the value of E, so I was able to derive the value of D. Now if I know D, in the similar way I can derive C, and if I know C I can derive B, and if I know B I can derive A. So I can derive all the rest of the elements having known at least one unique element. So the important question here is how to find out the first unique element. Like let's say how to find out this E. Let's take an example. If you have two set of values, like let's say you know A XOR B XOR C, and if you know A XOR B, then we can XOR them both, and these pairs, the same pairs, will get cancelled out and you will be left with the value of C. In the similar way, in our given problem statement, if I know A XOR B XOR C XOR D XOR E, and if I know A XOR B XOR C XOR D, if I XOR them together, then I'll get the value of E, right? Because all of the others are occurring in pairs. Now if you look at it, what will be the XOR of A, B, C, D and E? Actually, this is certain arrangement of numbers from 1 to 5, and they are all unique numbers. So it doesn't matter what is the ordering, but if you are finding the XOR in the range of 1 to 5, it will always be the same. Okay, so you can easily use a for loop in order to find XOR in range of 1 to 5. You can get it. And similarly, if you want to get the value of A, B, C, D, now in this case you cannot write that it will be XOR in the range of 1 to 4 because you don't know if E is actually 5. Now in order to get to this value, you have to actually do XOR of all the even jumps of values. Now why do you do only the even jumps of values? This is because if you are XORing all these numbers one after another, then it will be A XOR B, and then XOR it with B XOR C, then XOR it with C XOR D, and then XOR it with D XOR E. In this case, these two B's are common, C's are common, D's are common. So you will be left with only A XOR E value. And I do not want A XOR E, but instead I want A XOR B XOR C XOR D. So if you want that, you have to avoid the common elements. So how can you do that? If you make alternate size jump, that is the 0th jump, then second jump, then 4th jump and so on, then you will be avoiding all the common elements. Like if you do A XOR B and XOR it with C XOR D, then you will get this value A XOR B XOR C XOR D. So this is nothing but the XOR of 6 with 4, which is given here, 6 with 4, right? All the even jump elements, 0th and 2nd and 4th and so on. So like this you will get this value. Now once you have found XOR in the range of 1 to 5 easily by using for loop in order of n, then you will get the answer as 1. I have already written this. And on the other hand, if you do XOR of 6 with 4, like 6 is 1, 1, 0 and 4 is 1, 0, 0, then you will get 2. This is equals to 2, and hence I have written here 2. And if you do the XOR of this, you will get 3 as an answer. So we have derived 3, And I had already explained, if you get a value, then how to derive all the rest of the values. So it will be very easy to derive the rest of the values if you move backward, do the back calculation in order of n time. Okay, so the time complexity of this entire approach is order of n. Now you are expected to do better in finding XOR in the range of 1 to n. So instead of doing an order of n approach, you are expected to do it by order of 1 approach, and this is also very easy. This constant time approach has been explained in a video, XOR in a range. So the link will be in the description below. You can always go there and watch. Let us now look at the code. This part is actually how to find XOR in the range of 1 to n in order of 1 time. So this is explained in my video on XOR in a range. Now having known this, let us now look at the actual part of this problem. So in this problem, we were given the encoded array, and what we can do is we can find the size, that is the value of n, and then we have to make alternate jumps, that is the 0th index jump, then the second index, and then the 4th index, and so on, which was actually this value, this second parameter, this value. Okay, and in order to get this, you have to get XOR in the range of 1 to n. So the second value is XOR in the range of 1 to n. Okay, according to the previous API. So once you have got those two values, you have to XOR those two values together in order to get the unique element. And once you have got the unique element, that should always be included in your answer, which is the permutation array. And apart from that, you will have to do back calculation. Like if you know D XOR E is equals to something, let's say 6, and if you got to know E, which is the element here, and let's say this is 3, then you will do D XOR E, XOR it with the same element E on both the sides, and these two will get cancelled out. So D will be equals to 6 XOR E, which is equals to 3, and that is how you get the answer. And similarly, you do the back calculation and keep including all the elements into your permutation array, which is the answer array in this case. And finally, just return the answer array. So this is the entire solution for Decode XORed permutation. I hope this video was helpful. Please like the video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.